Welcome to Get Your FRQ On. This question is from 2001. It's question number 1, and it is calculator active. In the question stem, we are given two regions in quadrant 1 of the coordinate plane determined by the graphs of y equals tangent x and y equals 2 minus x cubed. These two functions intersect at some point in quadrant 1, and S is the region which is sort of in the upper left in that space, and R is the region that's sort of at the bottom of that space. Part 1 of this question simply asks us to find the area of the region R. In order to do that, we have to understand visually what this region looks like. For part of region R, the top boundary is determined by the graph of y equals tangent x, and for another part of R, the top boundary is determined by the graph of 2 minus x cubed. So in order to find this area, we have to split this integral up into two separate integrals. In order to do this properly, we have to determine where these two functions actually intersect so we understand where the bounds of our integrals need to be. All right, so in order to find the area of R, we need to know our bounds of integration. This includes the x-intercept of y equals 2x minus 2 minus x cubed, and the point of intersection between 2 minus x cubed and y equals tangent x. All right, it's a calculator active question, so use your calculator for at least some of this. I don't think you need to do it for finding the x-intercept of y equals 2 minus x cubed. That we can do pretty easily analytically. That's x equals the cube root of 2. All right, but the point of intersection between y equals tangent x and y equals 2 minus x cubed, that is not so easy to do analytically. We're going to use our calculator for that. And the point of intersection there is a point A comma B with coordinates 0.902155, comma 1.265751. And there's a couple of different things about the way I have this answer written. Notice I do have extra precision in here. This is an intermediate step. I know final answers have to be correct to 3 decimal places, whether rounded or truncated, but this is not a final answer, and we don't want to round so much with these values that our rounding causes our final answer to be off when it comes to 3 decimal places. So note the added precision here. Also, notice that I've defined an ordered pair A comma B to have those coordinates. Now there's a reason I did this. In a free response question, if you define something, you are allowed to use the shorthand notation for what you have defined. Now you have to do this explicitly, but since we wrote A comma B equals this point, I can now refer to the x coordinate of this point of intersection simply by using the capital letter A. And I can refer to the y coordinate of this point of intersection simply by referring to it as the capital letter B, and I don't have to write out all those decimals every time I write something in my response. All right, so because this is a calculator active question, use your calculator. Don't try to do this by hand, that's silly. All right, so the area of this region R, right, it's going to start with the integral from 0 to a of tangent x dx. And then we're going to add to that the integral from a to the cube root of 2. In other words, the x coordinate for the point of intersection to the x-intercept of the function 2 minus x cubed. And I'm just going to have my calculator do that work. That turns out to be 0.729. Okay, so that's the area of region R. That's all we have to do for that. In part B, we are asked to find the area of region S. Right, so we can use some of the same information that we found in the previous part. We know where the two functions intersect, the point A comma B with the coordinates that we found. So the area of region S would just be the integral from 0 to a of 2 minus x cubed minus tangent x dx. So we're taking our top function, the function that is above the other one, minus the bottom function, and on this interval from 0 to a, y equals 2 minus x cubed is above the graph of y equals tangent x, so this is the correct setup. And again, it's a calculator problem, so let your calculator do the calculus. That integral is 1.161. And in part C, we are asked to determine the volume of the solid when the region S is revolved about the x-axis. Now, because the region S has boundaries determined both by 2 minus x cubed and tangent x, there's a good chance we should expect to use the washer method here. And like we said before, the graph of y equals 2 minus x cubed is the upper boundary for region S, and y equals tangent x is the lower boundary. So our big radius function, capital R of x, would be y equals 2 minus x cubed. And our smaller radius function, little r of x, would be y equals tangent x. All right, so the volume of that solid, if we use the washer method, and you can split this up into two separate integrals, you don't have to. That first solid, I split it up into two, would be the pi times the integral from 0 to a of 2 minus x cubed squared. So now we're generating a disk, dx, minus pi times the integral from 0 to a of tangent of x squared dx. All right, so now I'm hollowing out the middle of this solid. And again, calculator active question, do not try to do this by hand. You're not going to be able to do this by hand. Let your calculator do this calculation for you. You do have to write the integral that you're trying to find. Do make sure you do that. You always want to communicate to the reader what you are asking your calculator to do for you. But once you've done that, if it's a calculator active question, let the calculator do the work. The value of this integral is 8.332, so that would be the volume of the solid when S is revolved around the x-axis.